Ever since I got my hands on a Steam Deck, I've been looking into Valve's previous projects. One of them was the Steam Machine, but getting your hands on a working one is pretty pricey. That's what led me down the rabbit hole of building my own. I have two main goals for this build. First, I want to fit everything into a small form factor PC case, something compact enough to look natural in a living room setup, while still being able to fit a full micro ATX motherboard. My second goal is to stay true to what the Steam Machine originally stood for, a Linux-based gaming system. Of course, we will be installing Windows as well, and we can't forget the best part, the Steam controller. Since the original Steam Machine was bundled with it, we have to make sure the Steam controller is fully compatible with our custom build. For parts, I'm mostly using older hardware I had laying around with a few exceptions. For those who are unfamiliar with the Steam Machine project, back in 2014, Valve was concerned about the direction that Microsoft was taking with Windows 8, and their response was partnering with Alienware to launch their own console-style PC. Unfortunately, it didn't sell well because it was overpriced. No brainer, it's Alienware. But not all of Valve's R&D went to waste. We got big picture mode out of it, which is still a staple of Steam today, and eventually the Steam Deck, which was a pioneer when it came out. It was the first handheld outside of the Switch that we got that was good. So why didn't more people switch over to steamos? And was the Steam Machine actually any good? Well, we're here to find out. Let's gather the parts and put together our own DIY Steam Machine. The first thing I needed was a small enough case to fit a full-fledged PC in without being too bulky. I searched on Amazon and found some solid options, but they were quite expensive and I wanted to keep the budget as low as possible. So I ended up buying a case from AliExpress, which took about a month and a half to arrive. But when it did not disappoint. To go along with that, I had an old micro ATX motherboard from a friend, and it originally housed a Ryzen 3 3200G, which I swapped out for a Ryzen 7 3700X that I also previously bought from AliExpress to do a completely different video, but this is what it ended up in. Heck yeah. To pair with that, I grabbed my old RTX 2080 that I had lying around, and honestly, these specs are pretty respectable and match up well with the higher end Steam Machine configuration. For cooling, I'm using the original AMD Prism. It's the one you get with like the Ryzen 7 processors. And the power supply I'm going to be using with this whole build is a 650 watt gold rated unit I had laying around. For storage, I originally installed a 250 gig M.2 SSD, thinking I had a secondary SSD laying around. In hindsight, I didn't, so I swapped it out for a 1TB M.2 and set it up for dual booting both operating systems using one drive. Now that we have all the parts for our PC, let's start putting it together. While assembling the DIY Steam Machine, I realized I forgot to order extra fans. I only had one spare fan, which I use as the exhaust fan. Because of that, I experienced a lot of heat buildup inside the case. Another thing I found a little odd was the power supply placement. It's mounted at the front of the case, acting as an exhaust fan as well, which helps circulate more air inside. So far, this is the biggest downside to this case. Since it's so small, the heat buildup can really impact the performance. You can either install fans at the top or bottom, but because of the tight space in keeping cables away from the bottom mounted fans, it is tricky. So the best option is to mount the fans at the top, which I'll be doing later on. Before moving on to installing the OS, I wanted to mention a few things. Linux is a very versatile operating system, but it can be demanding when it comes to setting up and configuring everything. Since I want to make this process accessible to everybody, I will walk you through how to install Linux along with the challenges I ran into. But if you're only interested in the Steam Machine's performance, feel free to skip ahead to the testing portion of the video. With that being said, let's move on to installing the OS. If you're installing Windows, the process is pretty simple. Just download the Windows Installer tool, create a bootable USB stick, plug it into your PC, and follow the installation steps. That's it. And you will have Windows installed on your PC. This is by far the easiest thing you can do out of this entire build. Linux, on the other hand, is a lot more complex. And honestly, I wasn't expecting just how overwhelming it can be. Since this build is supposed to be the Steam machine, or at least something close to it, my goal was to install some version of steamos. However, the original steamos from 2014 is no longer functional or compatible with modern games. The only wide available operating system is the Steam Deck OS. After digging around online, I found cachyOS, which includes many of the Steam Deck features, making it a solid choice for a home console OS. I went through the installing process, but then I hit a major roadblock. My research was out of date. cachyOS no longer supports NVIDIA drivers due to the compatibility issue with Valve's GameScope. That said, I did get it to install, but because of the missing drivers, any game I tried to play would crash immediately, so I decided to move on and find a different Linux distro that supports NVIDIA drivers, so we could actually play games on the system. That's when I came across cachyOS, which is based on Arch Linux. They advertised full NVIDIA driver support, so this was a no-brainer. Now, I know that there's tons of different Linux distros out there, and you might find a better one, or I might even find a better one than this one. But for now, this is what we're gonna roll with. Now that we picked our OS, let's get to installing it. To install the Linux OS on a USB, you'll need a tool like Rufus. If you decide you're going to use Rufus, start by selecting USB drive, then under boot selector, find the downloadable OS. Hit install and Rufus will create a bootable USB. Now let's plug it into our DIY Steam machine. If everything is working correctly, it should start booting into Linux. The first screen will give you two options, one for a normal OS without NVIDIA drivers and the other version with NVIDIA drivers. Since we're using an NVIDIA GPU, I will select the NVIDIA version. Once selected, you will see a bunch of text scrolling across the screen, and this process will take about 5 minutes. And then it will boot into the OS off the USB stick. Now that we have the OS running from the USB stick, we'll need to install it onto our M.2. This process is pretty straightforward. A help menu will pop up and you want to hit install cachyOS. Next, set your language, time zone, and keyboard configurations. Then choose the drive you want to install the OS on. Since we're dual booting, we're only going to be using 500 gigs out of our 1TB M.2. However, during the installation, Linux wouldn't let me partition the drive, so I had to go back to Windows and partition it manually. Once that's done, select the replace partition and choose the partition you want to override. Since Linux doesn't have much bloat, I went with the smaller partition. After that, hit next, and now we're at the desktop configuration screen. There are plenty of different styles to choose from, but I'm sticking with the default Primera desktop, which works just fine for what I need. Click next, and you see an option to download additional packs during the installation. Search whatever you need and hit next again. The next step is setting up your username and password. Choose a name for your computer, enter the password, and proceed to the next screen. Here you'll see a basic summary of your selections and how the OS will be installed. If everything looks good, go ahead and hit install. The installing process will take about 5 minutes. Once it's done, just hit finish and it will automatically reboot on its own. Now we have Linux officially installed on our computer, but we're not done yet. There still are a few configurations we need to take care of before we can start gaming. There are multiple ways to install software packets in Linux. While the packet manager works well, it can be tricky to navigate. Since I want to target specific packets, I followed the step-by-step guide from cachyOS's website and used the normal kernel command system. The first command I'm going to run is update. This ensures that the core systems are up to date. While it's not mandatory, it's definitely a good idea. Since this is an admin command, you'll need to enter the password you created earlier. Fortunately, since my system is fairly new, there was only one update needed, not bad at all. Next, we need to set up the firewall using UFW. Run this command in the terminal, sudo UFW enable, and then enter your password, and that's it. Your firewall is now active. Now, let's install the necessary game applications, including Steam and other game launchers like Epic Game Store and Origin. Run this command in the terminal: sudo pacman s cachyOS gaming application. Run this command in the kernel. You'll have to select from which package you want to install using 1 or 2, and then hit Y for yes, and this package will start to install. This step will take a few minutes since it's downloading a whole lot of data. Now that we got the game launchers installed, go ahead and open Steam. Once you have opened Steam, you need to log in, of course, then go to Steam settings. Then navigate to the compatibility tab, then enable force the use of Pacific Steam Play compatibility tool, then select Proton Experimental. This is a translation layer that allows Linux to run Windows games, as most are designed for x86 architecture. Once you've done that, your system is fully set up. Now that we got everything working properly, let's start gaming. I wanted to test a wide range of games and compare their performance against the Windows versions. Since this PC has 2 operating systems on it, it's easy to get accurate benchmarks on the same hardware. However, I had to tweak every single game to get the best performance. Because the system doesn't have an AMD graphic card, I couldn't take the advantage of Steam's game scope, which would have been a great optimizing tool. This would have made it a lot easier to game on Linux. To ensure fairness, I applied the same tweaks to both the Linux and Windows versions of each game so that they were on a leveled playing field. Starting off with the finals, because its anti-cheat supports Linux, making it a great game to show off on our DIY Steam machine, we started off with the Windows version of this game first to get a benchmark to compare to. With all the settings set to high, we were averaging about 60 to 90 FPS in multiplayer. Also, I turned off Nvidia's VSync to see the maximum possible frame rate. In the practice range, my frames hovered between 90 to 100, which isn't bad at all considering that the maxed out settings. However, I ran into a weird issue. My monitor was being detected as a 4K display in both operating systems, even though it's actually 1080 and 160 Hz. What the heck? Also, it's an on-brand monitor, so go figure. Overall, my average FPS in the finals on Windows was 64 in multiplayer, while it definitely was better in the practice range. Switching over to Linux, I first jumped into a practice range to enable a performance benchline. In the practice range, I was averaging 115 FPS with peaks hitting 160, which is really promising. However, I noticed a significant stutter when I was moving around, and I had a weird pixel issue when I first loaded the game up. Moving over to multiplayer, my FPS averaged about 69 to 80, which isn't bad, but the experience felt noticeably different. There was a lot of stuttering, and more importantly, my input felt laggy. This was the only game where I experienced this issue, and I'm not exactly sure how to fix it. It felt like my inputs had a significantly higher latency, making the game feel less responsive compared to Windows. And of course, if you guys have any sort of fixes to this problem, please let me know in the comments. I'm pretty much at a loss of what to do. Next up, I tested Marvel Rivals, which allows you to run it on Linux. With maxed out settings, I was averaging around 50 FPS, but if you lowered the settings to medium or high, you could easily hit 100 FPS. The gameplay was smooth and with no hiccups like I experienced in the finals. The input felt really responsive, and I was using the Steam controller, which worked great for this type of game. Switching over to the Windows version, I averaged 70 FPS, sometimes even hitting 100 on the same settings. Overall, Windows had a higher frame rate, but in terms of actual gameplay, both versions of the game felt fantastic. And again, if you drop the settings to like medium on Linux, you will get over 100 FPS without a problem. Our next game is Palworld. On Windows, Palworld averaged about 50 FPS on high settings, with peaks up to 81 FPS. However, there were a few moments where the FPS lagged heavily, especially during increased combat. On Linux, performance was noticeably better, averaging about 91 FPS with a 1% low of 47 FPS. These were the exact same settings as Windows, so I was surprised to see such a big difference. The one thing I noticed was that the CPU usage was much lower on Linux, which might explain the performance boost. The hiccups and lag spikes I experienced on Windows were absolutely completely gone. The only issue was some minor text glitches, but nothing major. I also wanted to test Halo Infinite, but it refused to launch on Linux. No matter what I tried, it would freeze on the shader compiling screen. Strangely, it runs fine on the Steam Deck, which is way less powerful, but probably has a better driver support. On Linux, CS2 averaged about 100 FPS on max settings, which isn't bad at all. I did notice some stuttering, especially when running around the map. On Windows, it ran significantly better, averaging about 100 to 120, and if you drop the settings to low, you're easily hit 200 plus FPS. But hey, it's CS2, what do you expect? You can easily get 500 frames out of this game. Overall, for CS, Windows had the edge in raw FPS, but Linux held up surprisingly well. For City Skylines, both Windows and Linux performed identically and averaged about 64 FPS. This was a bit surprising considering the game is a CPU heavy, but it's good to see performance staying consistent across both operating systems. I also tested a game demo that caught my eye. It's called Cubic Odyssey. It's like Minecraft meets Starfield or No Man's Sky. On Windows, the game averaged about 119 FPS, which isn't bad with max settings. But on Linux, it hit 200 FPS with no issue. That was kind of insane. That's probably the biggest FPS difference I saw between the two operating systems. So overall, the Windows versions of most of these games kept a higher frame rate. Personally, I think it comes down to Nvidia having better driver support on Windows, but Linux still held its own. Every game was playable, and while there were some stuttering issues, nothing game-breaking. Since this is going to be my dedicated living room PC, I also tested Steam's Big Picture mode. On Windows, it worked flawlessly with no delay, everything was smooth, and you could jump straight into any game. The Linux version worked too, but it felt a bit laggy. I tried enabling the GPU accelerator for web support, which made the interface feel like it was actually running at 60 FPS, but then all the menus glitched out and became completely pixelated, so I had to turn it off, which meant I was dealing with some lag in the big picture mode on Linux. At the start of the video, I asked the question, why weren't more people gaming on Linux? And honestly, I think the biggest problem is still the anti-cheat support. Back in the day, Linux gaming just wasn't great. The firmware wasn't bad, but it wasn't enough to replace a console experience. Valve has made major improvements, especially with the Steam Deck, and Big Picture mode is the best it's ever been. But if a game uses a certain type of anti-cheat, you just can't play it on Linux. And there's companies like Xbox and Epic Games which aren't making things any easier. Xbox doesn't support Linux at all, and of course, since Epic has made themselves the direct competitor to Steam, they have no reason to care about Linux support. There are a few games that I play a lot that simply just don't work on Linux, and that's a huge disappointment. And again, it just comes down to either not supporting it, the anti-cheat is not enabled on Linux, or you're Epic Games and you're the little brother in the situation. You're not sharing any of your games to your older brothers. It's right there. So after all the testing, is it actually worth building your own DIY Steam machine? Of course I'm gonna say yes, this thing was an absolute blast. But only if you do it right. The biggest takeaway from this whole project is do not use an NVIDIA GPU if you're building a Linux gaming PC, because NVIDIA refuses to open source their drivers. You're leaving a ton of performance on the table. Meanwhile, AMD does open source their drivers, which means everything just works way better on Linux. If you're planning to build a Linux PC or Steam machine, I highly recommend going with an AMD GPU for a Linux gaming build. My original plan was to pick up an RX 5700 for around $180, which honestly would have been a much better choice for the setup. But since I kept pushing this video back for so long, and I also wanted to stay true to what Alienware originally released, so I decided on using the RTX 2080, and honestly, this caused me a lot of issues. When I first started installing Linux operating systems, I ran into a ton of driver problems, so I wiped everything and tried a couple of different Linux distros. I tried cachyOS, which worked, but it didn't support NVIDIA at all, meaning I can't play any sort of games. So I switched over to cachyOS, which came with the built-in NVIDIA driver support. That finally got things up and running, but I still wasn't getting the max performance out of my GPU. And compared to an AMD card, I could tell I was leaving a lot of performance on the table just because of NVIDIA's drivers aren't optimized for Linux. On the bright side, Big Picture mode worked flawlessly with the Steam controller on both Windows and Linux. It was completely plug and play, which was a huge deal. I was really happy to see that Linux recognized the controller right away without any extra setups. So after everything, I do think it's worth building the Steam machine, but I think I'm going to be revisiting this project sooner than you expect. There are definitely some things I want to improve, like the lack of airflow in this case, and of course, I need to get rid of that NVIDIA GPU and switch to something that truly fits a steamos powered PC. Before I wrap everything up, let's go over the price breakdown for all the parts. In case you're thinking about building the exact same system, starting off with the case, I picked up this Powertrain X Gamer from AliExpress for 37 bucks. For the CPU, I went with an AMD Ryzen 7 3700, which I found used on AliExpress for around $79. The motherboard is an Asus Prime A320MF. Originally, you could find this board for $40 on Amazon, but if you're looking for a working one under $100, you can find it on eBay for $49. For coolers, I used, the stock AMD Prism, which you could find on AliExpress for 34 bucks. But honestly, you could pick up a $20, $17 cooler off Amazon and it would do the same job. For the GPU, I used an EVG RTX 2080, which I found on eBay from anywhere between $200 to $400. To be honest, I wouldn't recommend buying a 2080 today, but hey, do what you want. For storage, I went with a 1TB Western Digital Blue SSD, which cost around 55 bucks on Amazon. The power supply was a gold rated Sikatip unit. I had good experience with the 600 watt model, but when I upgraded to a higher wattage version, the unit nearly fried my PC. It burned out, I returned it, and ended up buying an Asus power supply for my main PC, so that 600 watt came out of my editing rig. But if you still want to go with the Sikatip unit, it should set you back about 80 bucks. Altogether, our total price is 534 bucks. I went with the $200 EVG GPU off eBay, so that's what this price adds up to. Honestly, that's not bad for a budget PC. Of course, we could have optimized the part selection a bit more, schizo it, find some great deals, but I was working with what I had laying around, and I really wanted to make this video happen. As for the Steam machine, it's officially taken its place in my living room as my main gaming PC in my home console setup. I will be trying to hook this thing up to my racing wheels and see if I can get the games like BMG Drive and Seta Corsa to work on Linux OS, but that's a future project. Of course, I will also be fixing a lot of the mistakes I made in this build, so expect an update in the future. If you found this video interesting, I highly recommend checking out the Steam controller video I made earlier on last year, and also checking out the Walmart setup video. I had a blast making those videos, and the Steam controller video is what led me to make this one. But as of that, I'm going to leave it here. You guys have a good one.